Okay guys, I'm Doc Lewis, and what I'd like to do with you over the next 30 minutes or so is bust a few of the common myths about fishing lures and about fish in general. Because many years ago I started to realise, as a budding aquatic scientist, I'm studying and I'm reading the fishing journals and I'm watching the fishing shows on TV, and I'm comparing what they're telling me with what the science is telling me, and they're two different things, right? And so I started to figure out, well, not everything I see in the fishing magazines or the TV is necessarily accurate. So what we're going to do is wade through a few things and break down some of these common myths and misconceptions, and hopefully give you a better idea on how to connect your lures to fish. Does that sound good? Yeah, everyone wants to catch more fish on lures? Yeah? There's about 4 people said yes then. Yeah, great, all right, we're online, okay. All right guys, just to give you a little bit of an indication of where I come from, I'm a lifelong lure fisherman, probably half the people here are, so that's nothing too startling. But I'm also a lure maker for most of that time. And one of the great things about making custom lures is it trains you to think about exactly what it is that causes a fish firstly to be attracted to a lure, and then secondly to take the next step and engulf that lure, right? So I've spent countless hours over the last few decades thinking about lures and fish and how to connect the two of them together. But then, as I mentioned, on top of that, I've got another layer. I'm an aquatic scientist, right? Because as a youth, during my school years, I was spending way too much time fishing, much to the disgust of my parents. And it came to that point where I was starting to get pressured to think about career paths, right? And I started to realise that pretty soon I was going to have to study, and then I'd have to get a real job, and that was going to eat into my fishing time. So I did the only thing that a bloke could do, and I studied aquatic science, right? Which meant that for the next 20 years I worked with a whole bunch of other aquatic scientists on fish and fish-related stuff, and I could think and talk and eat and breathe fishing 24/7, 365, get paid for it and call it a job, and everyone was happy. Right? But as I say, early on in my studies as an aquatic scientist, I started to see these things coming out in the fishing literature that just didn't quite add up. And the big difference between scientists and fishermen is, as a scientist you're trained to tease out all the information, right, and throw away the garbage and just concentrate on the facts. But as a fisherman, you get to stand up here and give your opinion, and everyone accepts that it's fact, right? So I've started taking a much more scientific and analytical approach to my fishing, and it's really improved my results. And what I want for you guys is to start to impart some of that knowledge and hopefully help you to improve your results as well. So what I've done, there's a lot of things I've done over the last 30 years that might be of interest, but I've narrowed it down to 5 that are a little bit entertaining, so we're going to have a bit of fun with it, but will also help you along. So the first big myth: who's ever been told, if you want to catch fish, you've got to start learning to think like a fish? Who's heard that? Yeah? I was about 6 when I was told that. Kid, if you want to catch fish, you've got to start thinking like a fish. Right? The next myth that I want to blow is that lure colour is really important for fish. Right? So I get in fights all the time over this stuff, but I'm going to show you why that's the case. Then we're going to talk about the fish's sense of hearing and how that affects their perception of lures, okay? Because sound's actually really important to fish, but it's probably one of the least understood things. We're going to talk about the fish's sense of smell, and I'll probably throw in a couple of hand grenades that might surprise you there about what the fish smell and don't smell. And then we're going to talk about the fish's sense of taste, and there's probably a few surprising things in there as well, right? So let's start off with that age-old saying, in order to catch fish, you've got to think like a fish, right? Who can see a problem with that? What's the problem with a human being thinking like a fish? Anyone? Well, fish aren't thinkers, are they? I mean, fish don't play chess. They don't read books. They're not thinkers. Okay, so this is obviously a human brain, right? And it might surprise you to know that what's between your ears, in most cases, makes up about 16% of your body weight. Right? I reckon that's pretty impressive, because we've got a whole skeletal system, we've got all these internal organs, we've got skin, and 16% of our total weight is what's between our ears. Now, I know a few people that are probably a fair bit below 16%. I'm sure you know a couple too. This one's a fish's brain, right? Now, what I should say about the brain, it has two functions. There's the core function stuff, right? That's keeping your heart beating. It's keeping all your organs working. It's making you respond to external stimuli, all that kind of stuff, so the core function. And then it's got the cognitive stuff. So that's the thinking, that's the learning, that's the remembering, right? So your brain does those two functions. Now, if you think about the fish's brain and you compare it with a human brain, the big difference is a fish's brain actually only makes up 0.4% of its body weight. Right? So our brain is 16%, the fish's brain is 0.4%. Right? So the human brain actually has about 40 times the function of a fish's brain, which means we've got a lot more capacity to learn, remember and figure stuff out. Right? There are some human beings that are able to dumb themselves down to the IQ of a fish. If you know where to look for them, you'll find plenty of them just in that location right there. But who wants to be one of those? Who wants to be able to think like a fish? Who wants to shut down 95% of their brain? Not me. So, look, fish are actually instinctive animals. So what they're basically doing the whole time is they're running these little programs. You know, if the barometric pressure does this, then I respond like this. If the water temperature does this, then I respond like this. And those buttons, when they get pushed, get the same response every time. Right? So as fishermen, if we know what buttons to push, right, we can make the fish do what we want them to do. The catch is, of course, that they've got a whole bunch of programs running. So they're not just running the barometric pressure one, they've also got water quality, water temperature, currents, tides, phase of the moon, all these things going on, so that starts to get a little bit complicated and they get a little bit unpredictable. But most of us will know somebody who's been fishing for a particular species for 40 years or fishing a particular location his whole life, and he can catch that fish every single time. He knows exactly when to go out, what to do, what buttons to push, right? So as fishermen, what we need to do is understand that fish don't think, they don't weigh up all their options and choose which one's the best. They react pretty much instinctively on stimuli, but they do learn from experience. Okay, because we all know that if you go and fish a lake that gets heavily fished, it's close to a major city, or it's had a big tournament on it or something like that, that the fish have probably learned to avoid lures and they're a bit harder to catch. So guys, don't think like a fish, think like a fisherman, but try and understand fish a little bit better, okay? And the best way to do that is to pick a particular species, one or two species, and really get to know that species. Okay, I'm going to move on to lure colour here. I'm ready for the tomatoes, okay? So I always get into fights over lure colour. So just a quick rundown on fish's eyesight first, and some of the things you probably need to know about how fish actually see things. Because we assume, because we're human and eyesight is one of our primary senses, we assume that fish also use eyesight as their primary sense, but they actually don't. And fish can get along quite happily without seeing anything, right? But as lure fishermen, quite often we're very, very focused on colour. So the first thing you need to know is that the fish's eyes focus differently to ours. And that means that they actually can't see, they can't focus on things that are a long way away. About 5 or 6 metres is about as far as a fish can focus. After that, it's just a blur, right? The other thing you need to know is that their eyes generally are on the sides of their heads, unless they're a flat fish, of course. They've got eyes on the sides of their heads, which means that they can see round behind them. So they can see your lure behind them, they can see it out to the sides, they can see it in front. But to the side and behind, they've got monocular vision, right? So they don't have depth perception. They can see your lure, they don't know how close it is, and they don't know how big it is. Once it gets in front of them, where their vision starts to cross over, then they get binocular vision and they can see the lure a lot better and they can know exactly how far away it is. Okay, this is Biology 101, okay? So just a quick rundown to put us all on the same page. This is how the eyes of every living animal, basically fish, birds, mammals, reptiles, amphibians, doesn't matter. This is how the eyes perceive colour. So we have sunlight coming down and striking an object. What do we know about sunlight? What's it made up of? All the visible colours, right? So red, orange, yellow, green, indigo, blue and violet, right? Plus there are some colours that are outside of the human range of vision. So there's infrared at the long wavelength end, there's ultraviolet at the short wavelength end. Now some fish can actually see ultraviolet, which might interest you, right? Anyway, that white light comes down, it strikes an object, some wavelengths are reflected, some wavelengths are absorbed. Now those wavelengths that are reflected, bounce off, they reach the fish's eye, go back to the retina does a little photochemical thing, sends a signal to the brain, and the brain interprets that as a colour. In this case, it's the green wavelengths. Now, this is different for fish than it is for humans because we're living in air. Fish are living in water. And water is a great filter. It's like a great big blue piece of cellophane that you put over your eyes, right? And the deeper you go into the water, the thicker that cellophane is, the darker the colour, right? So a lot of people don't realise that even in crystal clear water, those colours are being filtered out the deeper you go down, right? So the red, orange, yellow colours disappear first, the blues, the indigos, the violets penetrate the furthest into the water column, right? This is in crystal clear oceanic seawater. It gets even more complicated when the sun's low. It gets even more complicated when there's a bit of ripple on the surface or a bit of algae or whatever. So let's have a quick look at that. So if we were to put these two lures into water and we were to slowly drop them down deeper and deeper into the water, have a look and see how the colours change. Right, so have a look at the tip of that, the tail of that popper there, and compare the colour there to the head. Okay? And this is what the fish is seeing. So the colours are much more dull. You can still see the outline of the lure. You can see the contrast between that sort of dark colour and the white colour next to it. But that's basically what they're seeing. If there's a bit of algae in the water, then we've got a whole new layer, right? Because we can start to get this greeny tinge, and that filters out even more colour. Or if we've got a tannin-stained environment where we've got a lot of humic acids and tannic acids, that sort of stuff that are giving us like a tea colour to the water, that filters out colour even more. So at the end of the day, it really doesn't matter what the fish's eyes are capable of seeing, does it? Because if the colour's not there, if there's not enough light there, the colour doesn't exist. I mean, I can see every colour in this room, but you turn the lights off, I can't see any colour, and it's the same for the fish. But there's always somebody in the room who says, hang on, you're oversimplifying this, Greg. Now, the fish have lived in water for millions of years, so their eyes are adapted to see colour in water. Now, it's just that we can't see it. Well, unfortunately, guys, I'm going to burst your bubble if that's what you think. Because the way scientists can tell what colours animals can see, the way we know that, for example, bulls don't see red, right? The deer don't see orange. The dogs see largely in black and white. The way we know that is from the cellular structure of the retina of the eye, right? So what I've shown here is a couple of the key cells in the retina of all living animals. Okay, so we've got the rod cells. They're the purple ones there. Now the rod cells are the ones that are responsible for distinguishing between light and dark, right? So they give us contrast. It can be light blue, dark blue, light green, dark green, not just black and white, but light and dark, right? The cone cells are the ones that actually receive those wavelengths of light and send the signal to the brain that helps it to interpret colour. Now the difference between them is that rod cells work in really, really low light. Cone cells require a lot of light, right? And if you look at the ratio of rod cells to cone cells in the human eye, it's about 1 cone cell for every rod cell, every 20 rod cells. Okay, but in the fish's eyes, depending on species, it's about 1 rod cell, 1 cone cell for every 30 to 50 rod cells. Right? So what's that telling us about how fish see things? Yeah, they're not seeing a lot of colour, but they're seeing contrast really, really well, really strongly. So if you wanted to see how a fish sees a lure, next time you're watching a fishing show and they show underwater footage of a lure, get your remote out, hit the menu, turn the colour right down, turn the contrast right up. Okay, and that'll give you an idea of how fish see lures. So I'll just whiz through a couple of these. So environment's the biggest factor, and I always say to people, don't really obsess about colour, because really, unless you're fishing in clear water, shallow water, and the fish are adapted to see colour, they don't really see a lot of it. And there are other things that are much more important for getting a fish to your lure, and one of those is sound. So, who are the people here who go into a tackle shop, like I do, pick a lure up, give it a shake, and go, oh, geez, that sounds good, nice and loud? Who does that? I'm the only one that does it. Oh no. Oh, shame. Okay, well, let's explore why that's a bit of a fallacy. So fish use hunting, they use sound for hunting, they use it for mating, they use it for communication, they use it for navigation, right? Lots of different ways to use sound. And the reason they can do that is that sound actually travels much better through water than what light does. It travels 5 times faster through water than it does through air, and unlike human ears, fish's ears can actually tell which direction sound's coming from underwater. Our ears can't do that because it travels too fast for us. Now, low-pitched sounds are much more common underwater. They travel further, and they're just a more natural sound, and most of the natural sounds that are created underwater by non-human type things tend to be low-pitched. But it's a mistake to assume that just because a lure is loud to our ears, fish can hear it. Right? So, who are the dog owners in the room? Yeah? So, any of you guys own a training whistle, dog whistle? No? Do you know what a dog whistle is? Yeah, you've got one? Yeah, what happens when you blow a dog whistle? Yeah, so your dog straight away responds to it. What if you blow it really hard? It goes nuts, yeah. Because why is that? Spot on, yeah. So there's a high-pitched sound there that your dog's hearing and he's responding to it. And you can use it to train him because he hears that really, really clearly. What about you? Can you hear it? Yeah. Yeah, so generally speaking, we can't hear that sound. And the reason why is that dogs have a different audible range than what we do. Dogs can hear from around about 67 hertz up to 45,000 hertz, right? Whereas the human ear goes from about 20 hertz up to around 20,000 hertz. Okay? So the dog whistle slots right in here at around 26,000, so it's really easy for a dog to hear, but no matter how loud we blow it, we can't hear it, right? So who'd like to guess what the audible range is for fish? Anyone have a shot? It's low, yeah, you're right there. 10? It's about 1 to 1500 hertz. Okay, so there's a whole range of sounds in this area here that we can hear that fish can't, right? Which means that there's probably a whole lot of lures out there that make a whole lot of sound that fish can't hear. Right? So I always say to people, if you want a lure that fish can hear, you want something that's a low frequency, and the lowest frequency sounds come from either solid resin lures or timber lures that have rattles fitted in them. Okay, because those lures have a more solid substance, they've got a different resonance, and so the sound tends to be lower pitched. Now when I tell people this, they always say, oh yeah, but even though they can't hear it, they can still feel the vibration. Right? Because we all know fish feel vibration, don't they? Yeah? Where do they feel the vibration? The lateral line, yeah. So the lateral line's an organ that allows them to, is very, very sensitive to vibration. But the problem is the lateral line works at lower frequencies, not higher frequencies. So they can hear sounds that we can't at the lower end, and they can feel sounds that they can't hear. They can feel those vibrations at the lower end, but they can't hear those sounds at the higher end that we can hear. All right? Now, quite often at that lower end, it's not actually a rattle in the lure that they're hearing, it's actually the movement of the lure causing a vibration in the water, or the hooks against the body of the lure, right? So those vibrations are coming from that. Now, there's another consideration here as well, because fish, if sound travels really, really fast and fish can hear it really, really well, they can actually hear your lure if you're at the right frequency before they see it, right? So if you're fishing a heavily fished water and everybody else is using a lure that rattles that fish can hear, and they start to associate the sound of that rattle with something unpleasant, they become educated and they can actually be turned off before they've even seen your lure by the sound of it. So sounds can attract or repel. I say to people, think about, if you're walking down the street and you're walking past a local watering hole, you might not have been planning to go in and have a beer, but they've got a good band on. You hear some good music, what do? You probably go in and have a beer. But if you've set off to go to the watering hole and have a beer and you get there and there's somebody with a jackhammer in the foyer, are you going to stop and have a beer? No, you're probably going to get a couple of travellers and go home, right? So it's not just about the frequency of the sound and whether they can hear it. It's not just about the volume of the sound, but it's also about the sound being attractive to them, being something that's going to make them either curious or make them hungry or whatever it is. And I can't really advise you on what that's going to be that's appealing, because it varies from species to species. And some species are very, very timid, a little bit of sound will send them scurrying. Other species are inquisitive, and a bit of sound will bring them in. But I always say it's really worth experimenting with sound far more than it's worth experimenting with colour. Okay, because it can have a much bigger influence on the fish, and it can bring them from a lot further away than what the colour of your lure can. All right, who are the people here who fuel their boat up or fuel their car up the day before they go fishing because they don't want to get the smell on their hands, they don't want to transfer it to the lure and cause the fish to reject the lure? Who does that? Nobody? Who avoids getting sunscreen on their hands? Yeah, who avoids getting DEET on their hands? Yeah, let me tell you a few things about how fish smell things. Fish can't smell fuels or lubricants. Don't need to worry about petrol. Fish can't smell fish oils or shellfish oils. What? Yeah, it's the main thing we put in our burley, isn't it? We throw a bit of tuna oil in there. Why do we do that? So the fish can smell it. Doesn't work. Fish can't smell ethyl hexyl methoxycinnamate. What is ethyl hexyl methoxycinnamate? Sunscreen, yeah. They can't smell diethyl toluamide. What's that? DEET. And they can't smell essential oils like the essential oil of aniseed that's quite often used in scents that you put on lures. I'll explain why in a minute, but here are some things that they can smell. They can smell nicotine. So smokers, there's another hit for you guys. They can smell soaps and detergents. So when you get fuel on your hands, they can't smell that, but you go wash your hands and they can smell the soap. They can smell vegetable type stuff, garlic and that sort of thing. They can smell proteins exceptionally well in really, really low concentrations. So they can smell an earthworm, for instance. We can't smell that, right? And they smell a thing called bile acid. And this is really interesting because bile acid is something that's excreted by a fish after it's been feeding. So other fish will come along, they'll smell the bile acid and they'll go, oh, there's been some feeding going on here. This is a place to investigate. If I'm hungry, this is a good place to be, right? And they'll smell human smells, not the oils on your skin, which is what most people think, but sweat and that kind of stuff, right? So why is it that we can smell things like fuels and DEET and sunscreen, but fish can't? Any ideas? They're smelling water. So in our noses, we've got gaseous, or we've got stuff on the air that's coming in. So it could be gas, it could be a vapour, it could be some sort of particle that's being carried by the air, right? So it's coming into our nasal cavity, it's touching on our sensory receptors in our nasal cavity, and that's sending a signal to the brain, right? Fish work in much the same way. If I can just get the slides to catch up here. So fish work in much the same way. They've got nostril-like holes on their head, so they're called nares. They've got an anterior nair at the front where the water goes in, and then the posterior one where the water comes out. And as it flows through that little canal, it goes across a whole bunch of receptors, just like our nasal passage. The difference is that they've got water flowing through there, right? We've got air flowing through ours. Now, what do you know about fuels? Do they float? Yeah. Do they mix in water? No. What about fish oils? What about DEET? What about... So, in order for a fish to be able to smell something, it's got to be dissolved, or it's got to be suspended in water, okay? So that's why you don't need to worry too much about getting fuel on your hands and sunscreen and that sort of stuff. All right, last one. Fish spit lures that taste bad. Who's heard this before? Yeah? How about if you've got a soft plastic lure and you put a bit of a scent on it, you know, you can let it sit there a bit longer, fish will get it down a bit deeper. Have you heard that? Leave a bit longer before you set the hook. All right. Guys, I'm going to get some audience participation to illustrate this one. So I want everyone to get up off your seat. And I'm not going to talk until everyone's done what I'm saying, so everyone get up. Right, now I want you to take a few steps, find somebody that you don't know, and I want you to introduce yourself and shake hands with them. Right? And as you shake hands with that person, hold onto their hand, don't let go. Right? I want you to keep holding their hands. It's very romantic, very cosy, I know. Okay. Now close your eyes. And just imagine for a second that instead of having taste buds on your tongue, you have taste buds on your hands. And think about where that person's hands might have been. Okay, that's all I'm going to say. You can let go now. Thank the person whose hand you're shaking and take a seat. You see, one of the things about fish is that they do have some taste buds in their mouths. They don't have them on their tongue. They do have them in their mouths. But where else do they have taste buds? Pretty much everywhere. Right? So if you imagine, everything you touched, you tasted. Imagine going to the bathroom, dating, cleaning all that crud out the bottom of the dishwasher. It's not going to be much fun, is it? Because you're tasting all of that, right? And this is what fish are doing all the time. They've got taste buds on the sides of their face, down their lateral line, on their fins. If they've got barbels, they're usually heavily sort of encrusted with taste buds. Think about the poor old catfish. Some species of catfish have taste buds over their entire body. We've got 7,000 taste buds on our tongues, right? They can have 27,000 taste buds all over their bodies. And think about where they live, right? I don't think I'd like to be a catfish. So guys, have we got any barra fishermen in the room? Who's a barra fisherman? Yeah? What happens when a barra decides it's going to really take a lure? Boof! Yeah, the mouth opens, that lure goes choom, straight down to the back of the throat, doesn't it? Split second. Have you had days where all the barra are hooked on the side of the head? Yeah? Why is that? We say, oh, they're not really taking it, they're just slapping at it. Why would they be slapping at it? There's a couple of possibilities. One is they're just curious, and they're saying, what is this thing? And I'll give it a bit of a nudge. The other is, they're trying to taste it. Right? So those days when the barra are just slapping, and this, I've used barra as an example, but lots of other species do the same thing. The days when those fish are slapping the lure and getting hooked on the side of the head, that's probably the day to put a bit of scent on your lure. But make it a protein, water-based scent, not an oil-based one, right? So guys, that's the end of my presentation. Just a heads up for you guys, what I do, the way I make my crust is I teach people how to make wooden lures. Okay, and I teach people how to make lures that catch fish better than anything you can buy. So sorry for all the tackle dealers here, but if you're interested in that, I'm on a mission to get 10,000 people making lures and catching fish on their own homemade lures by the year 2020. And if you want to get in on that, you can come along, either hit me up after this, I'm going to be standing over the side there, or you can hit me up on email, support@MakeWoodenLures will find me. So guys, have I got any questions? I've got a few more minutes yet. If you've got any questions that you'd like to ask, I can answer them now, or you can come over and see me on the side of the stage and I'll answer them there. No questions? Okay, thanks guys. Appreciate your time.